Welcome guys to another video. If you're interested in learning how to solve simple tech problems, crafts, and studying, then you're in the right place. Please click on the subscribe box below and don't forget to tap on the notification bell. I'm your host, Creative Search Joe. For the sole reason that schools are not in session presently, today we will be learning maths, and the topic is algebraic expressions. Algebraic expressions are expressions that contains variables which are usually written as letters, operations such as plus, minus, division, multiplication, and numbers. Now, the expression written below, x plus 5, is an example of algebraic expressions. So, for us to really understand what algebraic expressions are, we need to know what numbers are, right? Now, in mathematics, we have what we call real numbers. Now, what are real numbers? Real numbers are generally any number you can think of, from 0 to 1000, minus 1, 2, minus 2, 4 over 3, 3.14. These are called real numbers. Now, real numbers can be classified into the following: natural numbers, whole numbers, integers, rational and irrational numbers. Now, we're going to be explaining what these numbers are. Natural numbers are numbers like 1, 2, 3, and the likes. Now, they do not include 0. They do not have negative numbers. They are not decimal. Decimals are like 1.5, 2.5, and so on. And fractions like 1 over 2, 4 over 3, and so on. So natural numbers do not include any of these. Now, whole numbers. Whole numbers are 0, 1, 2, 3, and the likes. Now, they include 0 and all natural numbers. They do not include decimal numbers or fractions. The next one is integers. Integers are like your minus 3, minus 2, minus 1, 0, 1, 2, 3. They're actually numbers that include negative and positive whole numbers. They do not include decimal numbers or fractions. The next is your rational numbers. Your rational numbers can be expressed as the ratio, the ratio of two integers. We already know what integers are. And it can be written as A over B, where your A are called numerators and your B are called denominators. Where A and B are integers and B is not, I repeat, B is not equals to 0. Okay, your A and B are integers, and B is not equal to 0. Now, examples of rational numbers are 1, which is also an integer, right? 1 can be derived from 1 divided by 1 or 5 divided by 5. Okay, that's how we can get our 1. Another example is 4. How can we get 4 with two integers? 4 is an integer divided by 1, which is also an integer. How else can we get 4? We can get 4 by 8 divided by 2. 8 is an integer, 2 is an integer. Another example is 0.3 with a bar on top. The bar actually represents a continuous 3. Okay, 0.3 bar is equals to 0.333333333 and 33333. Okay, now you get it, right? So these numbers are called rational numbers. Now let's move to, before we move, I would like to state something that with the examples given, this means that all integers are rational numbers. Okay, now let's move to irrational numbers. Examples of irrational numbers are like your pi in mathematics, your square root 2, your square root 3, and so on. Right? Irrational numbers cannot be written as a fraction with the numerator and denominator as integers. Okay? Now, let me try to explain further. Your pi, when you type your pi in your calculator, you have 3.14159265359 and so on and so forth. Okay, depending on what calculator you use. Some calculators stop at the nearest 15 decimal place. Okay, I'm going to explain what decimal places are as we move further. But these are irrational numbers. Irrational numbers are numbers that don't tend to end. They are continuous. Like your pi, like a square root 2. A square root 2, when you type it on a calculator, you have 1.4142135623 and so on and so forth. So these numbers are called irrational numbers. Now we move to the next subtopic, converting decimals into fraction. A decimal number has an integer part and a fraction part. For example, 5.315 has an integer part of or equal to 5 and the fraction equal to 0.315. Each digit after the decimal point is a fraction with a denominator in increasing power of 10. Now, when you add the integer plus the fraction, you see that it will give you that number, which is 5 plus 0.315 will give you 5.315. Okay? Now, just like I said, each digit after the decimal point is a fraction with a denominator in increasing power of 10. For example, you have 0.1. If you want to change that decimal to fraction, it will be 1 divided by 10. The next example is 0.01. You see, it is what? Increasing. The decimal point is the decimal place is increasing. So your denominator would increase in the power of 10. That's why we have 0.01 will give you 1 divided by 100. The next example is 0.001, which will give you what? 1 divided by 1000. Now, taking us back to the previous example we did, which was 5.315, we could see that the integer is 5 plus 3 divided by 10, which is the first place decimal point. Then the second place plus 1 divided by 100, and then plus 5 divided by 1000. When you add this together, you have 5,315 divided by 1,000. Okay, do you understand? Now, converting fractions into decimals, which is like the opposite of what we just did. To do that, we're going to give the previous answer, which is 5,315 divided by 1,000. How do we convert that into decimals? Okay, now to do that, for every whole number, well, this is my theory, there is an invisible decimal point at the extreme end. Yes, that one on red. Okay, for every number, whether 2, 15, 6, 6,000 and 2 and the likes, there is always a decimal point at the extreme end. That's why when you have numbers like 2.0, it simply means 2. If you have numbers like 125.0, it's actually 125. Okay? Now, to solve such question, the invisible point at the extreme end, when we're dividing, we're going to move that point to the extreme left. Okay? In this case, we have 1,000. How many zeros do we have in 1,000? 3. Yeah, 3. So we're going to move it 3 times. So that is 1, 2, 3. So 5,315 divided by 1,000 is going to give you 5.315. Do you understand? Okay, let's move to another example. Let's say you have 1 divided by 100. To do that, I said there's always an invisible dot, right, at the extreme end of any number, in this case 1. So we have the extreme dot here in red, and we have 100, so we're dividing by 100. How many zeros does or do 100 have? That's what? 2. So we're going to move twice. So that's 1, 2. Now we noticed, unlike the previous example, when we moved, there's like an empty space there. So for that empty space, we're going to put 0. And then we're going to put our dot. Okay? So 1 divided by 100 is, okay, after the dot, okay, we're going to put another 0. So the final answer will be what? 0.01. So when you have a decimal point before a number and there are no numbers, when you have a decimal point before numbers, okay, and there are no number before the decimal point, what do? You put 0. Okay, so 1 divided by 100 is what? 0.01. Okay, do we understand? Okay, now rounding off decimal numbers. Now, to round up decimal numbers simply is a way to approximate a number. For example, if you want to round off 3.62552 to the nearest, let's say 3 decimal place. Okay, now what are the rules? Okay, the first rule is to count 3 places after the decimal and place a line, a stroke, okay, drawn vertically between the 3rd and 4th number. Why is it between the 3rd and 4th number? Because we're looking for the what? We're looking for 3 decimal place, right? Or we're rounding up the number to 3 decimal place. So we're going to count 3 numbers, okay, and put a line there, okay? So the second rule states that round up the 3rd digit. Don't forget, we're trying to solve for 3 decimal place. So we're going to round up the 3rd digit if the 4th digit is greater than or equal to 5. Now, in this case of 3.62552, we've drawn our line after the 3rd number, right? Because we're looking for 3 decimal place, right? We're converting to 3 or rounding off to 3 decimal place, right? Now, the number after that line in this case is 5. And the rule says round up the 3rd number if the 4th digit is greater than or equal to 5. Rounding up a number means to increase it by 1. So in this case, the 4th number is equal to 5. So we're going to round up the 3rd number, okay? So the final answer is going to give us 3.626. So when they ask you to round off or to approximate 3.62552 to 3 decimal place, the final answer will be 3.626. The third rule states that you leave the 3rd digit if the 4th digit is less than 5. Let's say, for example, we have 3.62532, okay? And we're asked to approximate to 3 decimal points or 3 decimal place. What do? We're going to count 3 numbers after decimal point. Don't forget, it's always after the decimal point. Okay, we're going to count, we're going to draw our line. That's the line in blue or sky blue. Now the number after that line is 3, right? So our number is less than 5. So the rule says that we're going to leave the 3rd number. So if you're asked to convert or to round off 3.62532 to the nearest 3 decimal place, the final answer will be 3.625. Why? Because the fourth number is less than 5. Okay? Now, the fourth rule states that if the third digit is 9 and needs to be rounded up, then the 9 becomes 0 and the second digit is rounded up. Let me give you an example. Let's say we're given 3.62962. Okay? And we're asked to round up to 3 decimal place. So 3.62962, we're going to count 3 numbers after the decimal point. That's 6 is 1, 2 is 1, and 9. Then we draw our line to differentiate it. Now, after the line, we have 6. Don't forget our second rule that states that rounding up the third digit if the fourth digit is greater than or equal to 5. The fourth digit in this case is greater than 5, right? So we're going to be adding 1 to the third digit. So when we add 1 to 9, it's going to give us 10, right? So we're going to put 0 and we're going to take that 1 to the second digit to make it 3. In another case, I could say that when you're asked to round up a number, it means for you to add 1 to the decimal numbers. Okay? What do I mean? 3.629, right? We're adding 1 to 629. When you add 1 to 629, what does it give you? 630. Right? Yeah. So when you're asked to round up 3.62962 to 3 decimal points, the final answer will be 3.630. And there's another rule too, which is not part of this rule. When you have 0 at the extreme end of a number after the decimal point, you get to cancel that 0, because 0.20 is the same as 0.2. 0.010 is the same as 0.01. So this comes to the end of this video. We're going to resume in the next video. If you enjoyed it, please click on the like button. If you have any questions, no matter the questions, please leave it in the comment section below and I'll definitely answer your questions. And if you want us to continue with this, I will be asking for 100 likes. So that means you need to share this video to those that would be needing it. So until we meet next time, I remain my humble self, Creative Joe. Don't forget, it's okay to be different and creative. See you next time.